In the previous video, we looked at the requirements for the instrumental variable itself. Now we have to look at the assumptions for the whole instrumental variable regression. And for simplicity, we assume that the W's are all exogenous variables, so there are no control variables, which should control for the exogeneity of the instrumental variable. So if the W's are exogenous variables, then the assumption is as such. The expectation of, or the average value of the regression error terms conditioned on the level of the exogenous variables should be 0. And the draws, if you draw this data from the population, then for example, this is one observation, right? And then each observation should be independent and identically distributed from a joint distribution. So if you have one draw from the population, then that draw should not be correlated with the next draw or the previous draw, because then so you should not have any autocorrelation in your sampling. And more, large outliers should be unlikely. You might have an outlier in your data just by bad luck, which doesn't mean that there is a problem with the sample method. But if you continue to have these large outliers, then there might be some problems with your sampling method. And the instrument, the z's, should be relevant, which means that the slopes are different from 0, and they should be exogenous, which means that the correlation or covariance equivalently between the instrument and the population error term should be 0. So the question is, why do we care about these assumptions? Well, we care because if these assumptions hold, then our two-stage least squares estimator is consistent and it's normally distributed in large samples. Okay, so why is it important that it's consistent? It's because if it's consistent, then we know that if we take a lot of samples, then our sample estimate, the beta hat, is normally distributed around the true value, of the effect of x on y. And because it's normally distributed, we can make or perform hypothesis test, and we can make these t-values, p-values, and the confidence intervals to test our hypothesis.